Hello, and thank you very much for coming along to EcoViews and News once again. Today we want to focus on an issue that has gotten prominence in the press over the last 3 or 4 months, in part because people around the country and around the world are beginning to realize the implications of the fast melting character of both the North Pole and the South Pole, the Antarctica and the ice sheets in effect in the northern hemisphere as well. When I say they're beginning to recognize the implications are pretty dire, in fact very dire, because the rate at which things are happening at both poles and in the glaciers in between is a lot faster than anyone predicted, and the result is that sea level is rising much faster than anyone has predicted, and our thinking about it hasn't progressed as rapidly as it's occurring. So this is why we want to look at what we're calling big ideas and small thinking. We've got big ideas, especially when you approach engineers about this problem. Geoengineering has a series of solutions, namely building bigger and better dams out beyond the cities that are going to be affected by sea level rise. But this is a sad example of small thinking. Maybe big ideas, but it's really small thinking to think that we can take on sea level rise by protecting harbors. In other words, it's kind of approaching the question of a global problem with a series of local answers that won't have much future. Well, the reason why it's gotten a lot of attention is that places like the New York Times have devoted attention to it. Rising sea level seen as threat to coastal U.S. Well, that's kind of understatement, but they have graphic pictures of people in boats floating outside their homes, and you can see how quickly this captures the public imagination, even if the information on it is not that new. What's new is the rate at which this is occurring. It's occurring much faster than anyone predicted, and as it happens, Harvard has turned its attention to this. Its recent publication of Harvard Environment, its periodic publication coming from the Harvard University Center on the Environment, has looked at this and focused particularly on Boston. Corrigan, Ireland, has written an article in it called Rising Seas Imperiled Cities. Coastal regions must prepare, and Boston is a case study. Well, if you look at it, you can go out to it on the web. This is freely available. It's not just a Harvard publication, and you can punch into it at various levels and page through it and see what's involved, see the experts involved. People like Dan Schrag are beginning to talk about it, and you can page your way through the entire article, print it off if you like. They've got one expert after another. The author of the article is not themselves a scientist, but is writing on behalf of the scientists who are being interviewed here. And it's something that Harvard's beginning to spend a lot of attention on. And you ought to take a look at the several-page spread that they've put out for this, because it's very useful by way of those of us in Boston thinking about this problem and getting in touch with some of the latest thinking about it nationwide. You will recall, anybody who's faithfully watched this program, that we've dealt with some of this before. In 2010, we had a program called Envisioning Our Coastal Future, Part 1, looking at New York, Boston, Cambridge, and beyond, and we followed it up with Part 2, looking particularly at the seawalls that were envisaged for Boston, this big one that's supposed to encapsulate all of the islands, well, not all of the islands, but many of the major islands in the Boston harbor, with a new kind of defense and a sea lock that would basically keep this area inside, below sea level, and have a lock system available for ships to be able to pass into the Boston harbor. This is a system that has been proposed in the past, and we discussed it in this program back in 2010. In addition, we looked at one shortly thereafter, in 2010, on what it would look like if a storm surge overtopped the Charles River Dam. Now, this is the major dam that keeps sea level at bay, as it were. It keeps sea level beyond something that people in the Charles River Basin normally have to think about. Why? Well, because we don't really have a river here, even though we call it the Charles River. What we have is a puddle, an extended lake that's been made possible by a dam down by the Science Center right here that goes from Cambridge to Boston, and it blocks off the Charles River from the ocean. Normally its function is to keep this level pretty stable, and we don't have a tidal river here. The tides don't come in and come out. On the contrary, ever since 1910 when it was built, it's kind of flat, and it's meant to be that way. There's a very nice waterway in the center of the two cities, Cambridge and Boston. But it's very clear that with the rising sea level on this side of that dam, and with the potential for greater storm surge phenomena with severe weather, that dam is no longer sufficient to hold at bay a storm surge of even a Category 3, let alone a Category 4 or 5 hurricane, and that a storm surge, it is estimated in this map, of a Category 3 would overtop that dam and flood all of these parts that we've come to assume are dry land in Boston and Cambridge. Now, we shouldn't have assumed that for very long, because, as we know, this is called the Back Bay for a reason. It used to be a bay. In fact, most of Boston was a bay, and it was underwater. It has been filled in the greatest project for public works in the 19th century, the building of the Back Bay, as it were, using railroads to truck in granite from places as far as Quincy, and using fill from all over the area. It shouldn't surprise us that we're very near, and in fact below sea level in some places, and that we're saved by this one dam here, which at this point is about a foot and a half or a foot above storm surge of a Category 3 hurricane. Well, as the hurricanes get more intense and more frequent, and as sea level itself rises, storm surge comes in on top of that rising sea level, and it's quite probable that that'll be overtopped within the foreseeable future. This is what's causing some consternation. It's called the hockey stick of sea level rise. Now let's look at it briefly. What's involved here? The reporting on it comes from scientists.
Here with me today that can tell us a lot more about climate change. Josh Willis. Now, you're an oceanographer here at JPL, correct?
Well, I'm an oceanographer, but I study sea level rise and global warming, and really how the ocean fits into that whole global warming picture.
Okay, Josh, some people have questioned whether sea level is really continuing to rise or whether it's accelerating, and what that tells us about the warming of the planet.
Well, sea level is definitely rising. There's really no debate about that. Almost anywhere you look in the world, global sea level is rising, the volume of the ocean is increasing, and this has been going on for at least 100 years.
Okay, it's not a new phenomenon. It's been going on for 100 years, and the latest indication is that it's happening at an accelerated pace. In other words, the process, well known to scientists until now, has been accelerating. And here's what the scientists, in effect, are drawing our attention to in an increased sense of urgency.
And if you look back in time, it turns out that sea level was actually pretty stable over the last 2,000 years. So we've had about 2,000 years that we have decent measurements, not the best, but pretty good measurements. And we know that global sea level's been pretty stable during this time. There were a few ups and downs, but at the end of the record, global sea level began to rise. In the last 100, 200 years, it's begun to rise very, very quickly. We know from tide gauges that global sea level has increased by about 20 centimeters in the last 130, 150 years. That's the time when we have really good observations. And we can see that this is much faster than any global rise that could have happened over the previous couple thousand years. So we're beginning to get this emerging picture of a sea level hockey stick. In fact, sea level was very constant during our stable period of climate over most of the last 10,000 years. And then in the last 100, 150 years, it's begun to rise. And it's begun to rise quickly, and it's begun to accelerate. In fact, the best estimates of global sea level rise, even in the last 100 years, suggest that it's going faster and faster. So we've gone from 1 millimeter per year 100 years ago to 2 millimeters per year about 50 years ago to 3 millimeters per year today.
What's going to happen to the sea level rise? In the 20th century, the sea rose about 8 inches. You do the arithmetic, it's about 2 millimeters a year. Is that a huge change? No. Can we deal with it? Yes. Did we? Yes. Was it a big deal? No. Okay, that's cool. But what's going to happen in the future? Well, what's going to happen in the future, we're already up to 3.5 millimeters. That doesn't sound like that much, but again, do the arithmetic. That's a 50% increase in what the rate of rise was we saw in the 20th century.
My name's Jason Box. I've presented here at the AGU meeting a 200-year reconstruction of Greenland ice sheet sea level contribution. What I'm finding is that the recent increase in Greenland sea level contribution is at a steeper rate than that at a time in the last 200 years. That's consistent with climate warming that has been accelerating in the recent decades.
So this picture of an emerging hockey stick in global sea level rise is becoming clearer and clearer, and without a doubt, it's linked to global warming and human-caused climate change.
Wyatt?
Okay, now we could go on. In fact, you can go on from the website and look at this at length, this full set of interviews. The point that we're making here is very clear, that the hockey stick is not only present, but the pitch at which it's going up toward the right-hand side of it is even greater than anyone had calculated in previous century rates, and greater than we had been measuring just up until a few years ago. So this emerging science is leading to this notion of a movement like that. Now, the National Geographic has gotten in the act on their channel and made it available to everyone, so you can see it on TV these days. There's no excuse for not viewing it. They put out a program called Earth Underwater, which is worth viewing from time to time, especially noting who's talking when about what. In other words, the overlying commentary is not altogether to be relied upon, but when they're interviewing scientists, you have a chance to go out, take the name of the scientist, and do some research on what they're saying about sea level rise in places like New York City and other coastal cities. They've been quite dramatic in some of their statements, especially this fellow named Harold Wanless, who's the chair of geology at the University of Miami. He's made it quite clear what's likely to be forthcoming here. And it's probably worth our trying to look at his statement, if I can call it up for us here, to, in effect, be very clear about who is saying this. This isn't some newscaster or some weather report. This is the head of the University of Miami's geology department pointing at these things. And it's worth listening in detail to what he's got to say. It's not the last word, but start monitoring these things around the world and around the country in particular as people look at different cities one after another. This one was in particular, as I say, in reference to Miami, and we can take a look at it here.
After 4 feet of sea level rise, electricity supplies would be affected as coastal power plants are flooded. After 5 feet, some of Florida's freshwater resources would be contaminated with seawater, and the Everglades National Park becomes a vast bay. After 6 feet, millions of Floridians would have to evacuate the state.
So what's going to happen to Florida?
By 2100, we'll be at least 4 to 6 feet higher. So this tide, which is not a high tide, will be about here, up to here. There's no way that we can keep the sea back as it rises. Miami-Dade County will be severely diminished.
By 2100, after 6 feet of sea level rise, Miami would look like this.
Okay, well that's pretty dramatic. This is obviously a simulation, but when the head of the Department of Geology at the University of Miami is saying, look, this is what it's going to look like by the end of the century, then you've got to start paying attention. Now, Miami's not the only place, obviously, and in fact it's worth looking at some of the other areas that aren't like Miami. He points out that Miami is not a place where you can build a barrier around the harbor. Why? It's exposed all along the beach there. Miami Beach is a beach, and basically it's going under. But that's not true of a lot of other places, and there's been some thinking about building barrages. As I say, big ideas, but small thinking, as it turns out. Take a look, though, in San Francisco.
The world's coastlines are eroded.
Well, in fact, it's back here. I think I miscued it there, but let's try this one. If we can, if it'll respond. I'll have to recalibrate it here because it's starting at a different place. But you get the idea. Basically, we're going after one city after another, which is a kind of example of small thinking in a way. But it's small thinking in reference to a big problem, and you'd expect, as is the case, that engineers have big thinking out there for particular projects. But that's just a particular project. It's not a solution to the problem. And in fact, it may be just postponing the problem at best, and it may be aggravating the problem because it doesn't so much solve it as displace it. It pushes sea level rise off onto other more vulnerable areas. And we can see that in reference to some of the other regions of the world that are experiencing it. Let's take a look, if we can find it now, to the San Francisco situation.
But there may be a way to defend both the Delta and San Francisco Bay.
San Francisco is among the best, easiest to save. The most radical solution would be putting a big dam right across the bay under the Golden Gate Bridge.
On the ocean side, the sea is about 130 feet deep. Building a dam would be controversial and would turn the bay into a freshwater lagoon. But at a time of intense sea level rise, some may consider this the best option. Using cutting-edge technology, huge dredgers could pick up sand from the seabed nearby and deposit it as the dam's foundation. The dam's shallow incline would ensure maximum stability against earthquakes, breaking the power of the ocean waves with ease. Vast pipes and pumps would be installed to keep the bay's river water flowing out to sea. The Golden Gate Dam would cost $2.5 billion and could be heightened to deal with any sea level rise in the future. San Francisco and the Bay Area would be saved. One region that may benefit from the U.S.'s sea defenses is the Mediterranean. It's flanked by countries both rich and poor, that have thousands of years of history. The Mediterranean has a unique feature, a narrowing at its mouth. The Straits of Gibraltar are between 10 and 20 miles wide, stretching from southern Spain to Africa. A dam could keep the rising water of the Atlantic separate from the Mediterranean.
There's been a plan since World War II, for instance, to put a dam between the Rock of Gibraltar and Morocco on the African side. A dam big enough that sea level rise does not affect the Mediterranean.
Now, you can see that this is an example of a big idea, but small thinking. Because it worked in San Francisco, and it hasn't worked in San Francisco, but the logic is that if you did it in San Francisco across the strait like that, in the San Francisco Bay, you could do it between Morocco and North Africa. Even a bigger thought, right? Well, it's big thinking, but it's, in some respects, small thinking too, because you can't keep the whole ocean out of another whole ocean without radically changing the whole ecosystem. And this is what we're up against. We've got, in effect, big ideas with a whole set of small thinking that's now going forward, and no real way to retrieve the problem. This is the kind of dilemma we're in. If we were to look at this a bit more thoroughly, you'd see, in effect, that we're in the presence of big ideas but small thinking in reference to sea level, and we've got to move beyond that. Thank you very much. Tune in next week, and we'll see you again.